There we go. Now we're recording. Okay. All right. So Lincoln's not talking, of course. Let's look at the slideshow that goes with this, and then you're going to fill in. Jackson, can you shut the door for us, please? And then, like I said, if I see you doing anything else, then everybody's got to come down to the floor and sit. So as of right now, you're okay, but I'll be watching. I'm looking around to see who might be just drawing pictures, not filling in stuff. And we're going to fill in stuff as we go, okay? At least that's in theory how this is supposed to work. All right, so we're going to talk about forms of energy. And then today we'll talk, well, after that, then we're going to start reading a little bit more about electricity. And we'll do that for the next few days. Okay. So, current, all about forms of energy. Energy is the ability to do work. I see Mason writing that down right now. I hope some other people are too. Because I'll probably have you turn this in when we're all done, and you'll get easy points for having it done and following directions. So energy is the ability to do work. We're going to learn about 5 forms of energy here. Okay. What forms of energy do you see? Oh, all different forms of energy. What? You didn't finish? Oh my goodness. Okay. There it is, right there. No, you don't have to write. We will learn about the 5 forms of energy. You just have to write what is energy. It is the ability to do work. Everybody got that? Yeah. What forms of energy do you see? So what do you see in terms of forms of energy? Some of them are obvious. Some of them you think about. One of them we've already been working with a little bit. Yesterday, Wednesday, last week. What's a form of energy you see, Sam?
Electricity.
Electrical energy. I don't know if I can write on this or not. No, I can't. Okay. Electrical energy. What's another form of energy you see?
Circuit.
Well, that's the electrical.
Okay.
Okay, the battery powering that. That's okay. What else, Jackson?
Right.
There is light energy. Okay. What else? Bailey? Sound energy. What else, Maxim? How about kinetic energy? Probably. That's probably the car. Energy in motion, probably. Okay. Aiden?
Fire.
Or how about heat energy? Okay, let's go on. Good.
Wait, what do we write down for this?
Nothing right now. Now we're at sound energy, and there are boxes for sound energy, and there are 3 bullet points, and that's what we'll write down for sound energy. So Parker, make sure you get these, because I'm going to have you turn this in, and it's going to be an easy grade. And if it's not done, well, then you're in trouble. And if it's easier for you to sit down here, of course you may, but you don't have to. Sound energy is produced by vibrations. If you've ever been somewhere or heard a car that's got a really loud bass, that you can feel those vibrations even, or a big, truck has gone by your house, and you can feel the vibrations from that. Or earthquake. Sound energy travels in waves, just like, that's why, like for the Wi-Fi, it's got the waves, because that travels in radio waves. Well, so does sound energy, travels in waves also. And it does not travel through empty space. It must travel through matter. Is that confusing?
Says does not travel through an empty space.
Yeah, you have to
We
get all
have to
that.
write the must.
Yes, it must travel. That's important that it must travel through matter. Now, why would that be confusing? Is that confusing? If that's confusing to anybody, be honest and tell me, so we can talk about why maybe it's confusing. Because I play music in the morning, and this seems like a big empty space to me sometimes. And yet, don't you hear the sound when I'm playing it? You put exactly what it says there, word for word.
You don't have to say it first, but again,
It must travel through matter. So why is it that when I put that speaker on and I play that music in this big empty space, why do we hear it? Because this right here says sound waves don't travel through empty space. They have to travel through matter.
in there.
What do you think, Miss Gigi? Well, yeah, but the speaker's over here, you're over there, and you can hear it still. So somehow the waves are getting you in this big empty space, it seems like.
Echo.
No, echo would still require the sound to bounce off something. Bailey. Oh, I can't hear Bailey. Well, the speaker is plugged in sometimes, but still the sound comes out of the speaker and it's not right up against your ear. That sound is traveling through this big empty space to you. I don't understand it. It said, well, it says sound waves do not travel through empty space. Kylie? No, but to bounce off walls, it has to get to the walls, right? So what is it about this? Sam?
We're in the empty space.
Well, I know we're in the empty space, but the sound wave still has to get to you somehow. And it says it doesn't travel through empty space, it has to travel through matter. Well, raise your hand. Don't yell things out loud. Ada? What, isn't air part of empty space?
Yes.
Air is matter. There, even though you don't see it, if you take your hand or you have a fan, you feel the air blow from the fan, right? That means there are molecules to be pushed. There's not nothing here. If air was not, if this room was really full of nothing, then if a fan was blowing, nothing would happen. Lincoln, please stop. Okay. So by that, they mean like space. Space is a vacuum. There is no matter. If we were in space and you were over there and I was at this end and I played the speaker, you wouldn't hear it. That's why when you watch movies and you hear sound, when things blow up in space, you know, and you hear sound, there's really no sound. It's silent because there's no air, there are no molecules to transfer those sound waves. So that's one fake thing about movies you see in space is when you hear sound, things blow up. So that's why we hear it in here, because air is matter. Air has weight. That's why when we talk about comparing mass and weight, when we do mass, we use one of those pan balances, right? And you put some little cubes in and you put something here and you get it to balance and you know what its mass is, how much stuff is in it. But if I take those items and set them on a scale, like you weigh yourself with, it's going to weigh a different amount because it's going to include the air that's pushing down on it because of gravity. Air is actually matter. Okay, that's why we don't weigh the same thing on Earth as we do on the moon, because on the moon there's less air, a lot less. Okay, so make sure you have that written down. Sound energy does not travel through empty space, must travel through matter. Let's talk about a different kind of energy. Leah, I hope you get this down. Light energy. It also travels in waves and in a straight line, which is why we go out on the playground and we walk around the corner and the sun's at this end, all of a sudden you see a shadow line on the ground, right? And then you're in a dark kind of space because that light doesn't go to the corner and turn the corner. Otherwise, there wouldn't be shadows. Everything would be light. And the natural sources of light energy would be sun and fire. And yes, it travels through empty space, which is why the sun gets to us, because it travels, light energy travels through the vacuum of space, why it gets to us.
And then also I've traveled through air.
Yeah, it travels through air.
So I can
That's
put
why
air.
we can
That's
see
why
the
I put
light
air
in
on
there.
here.
Go quickly. Make sure you get everything written down. Make sure you write your name at the top of this so that I can give you easy points. What, Maxie?
Am I able to take my shoes off because I signed up?
As long as you don't have stinky feet. And make sure you can put them on quickly. If we had like a fire drill or something like that, we had to leave quickly. That's the only caveat. You don't
We
have to
already
have.
had one this one.
I know.
It could be a week.
Shh, go look it up. Okay, I'm moving on. I'm assuming we got light energy. Gigi, we good? She says, hold on now. And then I'll keep, somebody who's got nice, neat handwriting, I'll keep yours probably and pass it on to Briasia and Joseph so they can get this copy down so they can kind of see this too. Okay, we're ready? Thermal energy. Think of the word therm means heat, right? Think of a thermometer that measures heat. So therm means heat. So if you see therm as a part of a word, think it probably has something to do with heat. It is also known as heat energy. The hotter something gets, the faster the molecules are moving. And so those are the two things you need to write down for thermal energy. Heat energy is how you cook your food on the stove, right?
It's heat waves. We're ready.
But we're not. There's still some people writing. Come on.
Know how we're looking.
Okay. So we did light energy, sound energy, and
Thermal.
thermal energy. Let's do mechanical energy or kinetic energy. It is the energy of motion, something moving. Kinetic energy is the same as a moving object. That's what we're really talking about with mechanical energy. Potential energy is an object at rest. So they're saying there's two parts to mechanical energy. If think about when we talk about potential energy, think about that roller coaster at the very top of the track, right? It has the potential to go. And once it starts turning the hill and going down, now all of a sudden it has kinetic energy. It's an object at rest, or it's an object getting, it's an object that has the potential to be moving. So it's not just, it does say an object at rest is what it says. So if you take a rubber band, you stretch it back like this and you're hanging on to it, that is potential energy, right? Because as soon as I let go of it, then it has kinetic energy because it's moving. Yeah, you don't need to do it.
Don't you get yourself in a hurry.
Jason, please. Please. Link. Okay, we all got it? Ella's ready. Jojo's ready. Now we get to electrical energy. Parker, let's put that away, please. Electrical energy, which is what we worked with yesterday and we worked with Wednesday. It is the movement of charged particles. It's electrical energy. It is produced in power plants from fossil fuels or alternative energy sources. we'd pretty much be lost without it. Our society.
Good thing we have potatoes.
Oh, I stopped at one table, didn't I? Did I stop at one table? What'd you say, Benson? No, we'll do that tomorrow, and once the final four set, then we'll do it. We don't need to talk about it. Okay, we don't need to talk about it. Here we go. What form of energy does this flashlight produce? So it uses electrical energy to produce what kind of energy, Sam?
Mechanical.
No, no. Bailey, light energy. And if you get your hand right up to it, depending on what kind of bulbs there, it might produce some heat energy as
So
well.
technically it's thermal and light.
Could be, depends on what kind of bulb. Answer is light. What form of energy does the bicycle produce? Ashley. So it's mechanical energy, and when it's resting and there's a guy on it and got his foot on the pedal, it might have potential energy, and then once he starts moving his legs and moving, then it's going to have kinetic energy. Oh, do those go there? What does it say? Oh, examples of energy changing form. Let's see. Light and thermal. Okay, here we go. Example one. So energy can change forms. Example one. Solar energy becomes electrical energy, and then it changes into light energy, right? So energy can change forms. That's example one. You can write, you can get it in there as best you can with a little sketch. You want? Yeah. Yes. This is example one.
No, it's energy. It's at the top.
Might help. Draw a little sketch. Parker, you should get this all written down, and you should have a little sketch drawn too. Okay. Jason, you've heard enough about the data. You need to stop. You need to stop. We don't need elaborate drawings, just a little sketch. The sun, a little square for a solar panel, and then light energy. Okay, you ready? Someone said no.
I have.
If I ask for it, I'll plan it, okay? I'm not taking questions. Or I don't want an example right now. If I ask for it, then yes, I will absolutely recall. Here comes example two of energy changing form. Jojo, you ready? I'm talking. I don't care who started. Keep going. Keep going. Example 2. No. Hold it. Well, one friend's not ready, or some friends aren't ready. Make sure you got that, friends. Sure, all friends are ready. Yeah. I know. Example 2, energy can change from one form to another. Batteries have chemical energy in them. They didn't show that as type minutes, did they? The batteries are full of chemicals that combine together to create, in this case, sound energy, but really they make electrical energy first, then they make sound energy. They should have put that there, but they didn't. That's okay. So it's really chemical to electrical to sound. I hear it again. Ready? Oh, okay. We don't need to all yell. Yeah, that doesn't help. I like Bailey's nice, simple thumbs up when she's ready. Showed me she's ready. She didn't have to yell. She didn't create a lot of sound energy. Some of us are very good at creating.
I like sound energy.
Example 3 is coming. No. Energy can change from one form to another. Example 3. When you plug the TV in, you got electrical energy coming in, and what comes out is light and sound energy. So it's energy changing form. You ever get a question about energy changing forms? You know that it does. Don't spend too much time drawing elaborate pictures. Make them quick little sketches. Okay. And example 4. Energy can change from one form to another. Example 4, mechanical energy changing into electrical energy. Pretty simple. Real simple, just important takeaway from this, takeaways are there are different types of energy, right? Energy takes different forms, and energy can change form. You can remember those two things. It's going to help you as we go forward. What's neat, Jackson? Are we ready? Bailey's ready to move on. Yeah. Make sure to write your name at the top on the front. Because I will have you, when we line up for music here in a bit, I will have you turn it in. And you give you easy points for having it all done. Next slide. What form of energy did you use this morning before you arrived at school? There should be multiple answers. By raising our hand, we'll see. Carter. Carter used some mechanical energy. Sam. Also mechanical. Bailey. Which one? Oh, light and sound. Yes. Good. Lincoln. Okay, yeah. I figure you use lots of electrical. Jackson. What? I can't hear you.
Thermal.
Oh, heat. I couldn't hear. Thermal. Okay. Got it. Good enough. Oh, that's it. All right, next thing. So this will go in the tray with your name on it, but not right now. Because I'm not going to have 25 people getting up, 24 people getting up, dropping things in the tray. When you line up for special. Now, when you go to specials, so make sure we're listening. So we hear. I don't have everybody listening. I have some people listening very well, but some people not so much. You're going to want to take, Jackson, I hope you're listening. You're going to want to take your iPad when you go. We still have like 10 minutes. But when you go, you'll want your iPad and you'll want your art box set also. Okay. Just so you know. All right. So now we're going to take out our iPad. Speaking of electrical energy and light energy and sound energy. Take out our iPad. Okay. And we'll stop our recording, I think, for this part. Right.